Get right into this. So right at the start, I'm going to come down here real fast. Actually, I'll go ahead and just give a quick overview. So BYU, they studied 59 students that would represent approximately 30,000 moviegoers. They would own a 20% market share, and they wanted to basically estimate what the demand curve is for movie tickets at these specified prices right here. Down at the bottom, in the table, we had summed up the amount of moviegoers for each number. And what I did here to basically scale this survey that they took to the real market, I took the number that we were given right here, and I multiplied that by 30,000 over 60, which is the 30,000 moviegoers divided by the 60 that they studied to give a correct market sizing, and multiplied that by 0.2 because it said they would own about 20% of the market share. So that's where these numbers come from. That's a little bit of an overview before I get into these questions. Question 1, graph the demand curve for the proposed dollar movie theater. Right here we see this demand curve. Basically what I did, I took each price point, I took the quantities that I just shared below, and I put them in this table, and then I went ahead and just used a scatter plot or a cluster. Sorry, I forgot kind of what it's called. One of the two. I think it's a scatter plot. We'll go ahead and call it that. Let me double check. Yeah, it's a scatter plot. So I put them into a scatter plot right here so that we can see just how this would look as a demand curve. I used ticket price down here and quantity up here because we want to see how ticket price affects the demand. Question 2 says, estimate the formula for the demand curve. Basically, we took the same data from above, implanted it right down here, and then we created a trend line. And if you click on this trend line, we have the option to display equation on chart. And so that's what I did. And that gives us this y is equal to 29,265 e to the negative 0.686x. Basically, that x means when you plug in one of these numbers, you're going to receive one of these demands anywhere along that trend line. That's what the average is. That's what the estimated demand curve is. Question 3 says, using a demand schedule or a formula, how many tickets will the theater sell in a month at a price of $2, $1, and $0? So to go ahead with this, I just created this little chart right here with a few extra prices to create a little demand schedule. You can see I use this where I just basically plugged in the formula, this formula that we had right here. I plugged it in for quantity, and then it goes ahead and automatically puts in this L50, which is the price. So it plugs that in here, and it chugs out this quantity right here. So at $0, the quantity is 29,265. At a ticket price of $1, it's estimated that they would sell 14,737 tickets per month. And then at $2, it's estimated they would sell about 7,422 tickets per month. Question 4, if the theater is charging a ticket price of $1, would total ticket revenue increase or decrease with an increase in price? Down here you can see if selling at $1, you see before it was at $13,120, and if you're selling at $1, it's still an increase. And even further at $125, the revenue continues to increase. Does this imply elastic or inelastic demand at a price of $1? For question 1. Down here, I say inelastic because total revenue is still increasing. That means that, price increase is still going to lead to an increase in total revenue. Therefore, it's inelastic. The demand is still going to go up, or excuse me, not the demand is going to go up, but the revenue is going to go up with increases in price. Question 6, compute the own price elasticity for $2, $1, and 50 cents. So question 6 down here, I have each of those marks. I have 50 cents, $1, and $2. And for each of these price points, I used a price elasticity of just 1 cent higher. So that's where I'm getting those numbers from. We have the quantities that are continuous from above, just using this formula up here. So that's where we get our quantities from. Whoops. And then the elasticity right here is a measure of this quantity, or it's quantity in the future basically, minus the quantity of 0 over the quantity of 0, and then that whole fraction divided by this price 1 minus price 0 over price 0 again, gives you the elasticity. So this one being less than 1, and this one also, or I guess you can say the absolute value being less than 1 and the absolute value being less than 1, both of these are inelastic. Whereas at $2, the absolute value of this elasticity is 1.37, which is above $1, or excuse me, 1, which means that it's elastic. And that is pretty consistent because you can see from here to here, revenue goes down. From here to here, revenue goes up. Revenue from here to here goes up. That's why inelastic, inelastic, and elastic. Question 7. Using Excel solver, find the price and quantity at which demand is unitary elastic for part A. So part A, right here, basically none of this information was in here. What I did is I plugged in, or I guess some of it was, I plugged in these functions. This is the elasticity function from the last one. And then I plugged in this function, which is the standard quantity function we've been using. And then I had solver find the maximum for this right here. So if we go to data and solver, basically it was finding at L100, this up here, which is this 1.46, which wasn't there before. And it's saying we want to find the max value with these constraints. So it had to be less than 2 because 2 is elastic, and it had to be greater than 1 because 1 was inelastic, and then N100, this elasticity, has to be equal to -1 because that would mean it's unit elastic. So with this, the number that it chugs out is 1.46. And that is the unit elastic price, which gives you revenue of this. And you can see again that that makes sense. I'm sure obviously if I were to lay out the data, you would see it specifically, but these numbers are very close and it starts to go down. If I were to do 145, these numbers would also be very close, but it would go up from 145 to 146. Question 7b says, using small increments like you just did in 6 above, find the revenue maximizing price and quantity, just like we talked about. 144, 145, negative 0.98, negative 0.99, and then you hit 1 at 146, and if you go in a little bit further, this is like negative 1.0001 or something like that, but this one is about as close to -1 that you can get. And you can see that revenue is increasing until it hits this point, and then once it hits this point, it starts decreasing, and it's very slight, but that is the maximum price. Question 8, if you're running a theater and interested only in maximizing ticket revenue, which price would you charge for admission? Again, 146, that's the revenue maximizing price. And then if you round the ticket price to the nearest $0.50 to avoid penny change, how much less will your total revenue be if you charge the exact revenue maximizing price? So revenue maximizing price we said was 146 at 10,749 units, gives you 15,693.85. And then if you round it up to the nearest $0.50, you're selling about 300 less tickets at a higher price for about $6.45 less in revenue. Obviously, this might be beneficial because sometimes the way that people read off prices, it relates to them a little more when they see a flat number like 150 as opposed to 146. And these are just demand estimates after all. So if we round it up to 150 to avoid penny change, then the estimated revenue would decrease by $6.45. That's the whole first problem. Hope that makes sense. We're going to move on to the second section. This is another survey of the same 59 students. This time they were asked what dollar amount they would spend on concession at the given admission prices. So this is going to be a cross-price elasticity problem, essentially. We're going to go ahead and start. It says, number 1, plot the relationship between ticket price and total concession revenue. So we have the prices, we have the number of tickets that they were selling at those prices from the previous slide. And then from here, we can see the average concession revenue at each price. And that's listed right here. And then this concession revenue right here is just basically the multiplying of the average concession times the number of tickets. So that's where we get this chart. And then to make this table over here, because it says plot the relationship, what we did is we took concession revenue right here, and we put that on the x-axis. Then we take price over here, we put that on the y-axis, and we find that at $3, you're not bringing in much concession revenue. At $0, you're bringing in a ton of concession revenue, and everything in between right there. Yeah, that's everything for part 1. Part 2 says, what is the cross price elasticity between price of a ticket and the amount spent on concessions? So we're finding the change in concessions over the change in ticket price. Basically what I did to find this. So I did one for the average ticket price. I also did one for the total concessions. I believe that it asked for, I guess it doesn't say explicitly, so I'll show you how I did each of them. So to find the cross price elasticity of the average, we took this M27, which is basically that same as saying quantity 1 minus quantity 0 over quantity 0. All of that over price 1 minus price 0 over price 0. When you put that into this function up here, it gives you the cross price elasticity. That function is the elasticity function that we discussed on the first problem. And that is how that works. Same exact thing over here, except instead of using the average concession price, we were using the total concession, and we were using that as it relates to the price of the movie ticket. And that is where we get each of these numbers. You can see that it's elastic while the price is very high. When people are spending $3 on a movie ticket, they are less apt to go ahead and buy concessions. When prices are really low, the demand for those concessions is actually very high. Question 3 says, does this imply that concessions and tickets are substitutes or complements? I'll read my answer. It says concessions and tickets would be complements because of the price-demand relationship between the two. When the price of the movie ticket increases, it causes the demand for the concessions to decrease. Conversely, when the price of movie tickets decreases, the demand for concessions increases. Thus, the two products have a supply and demand that works together. Remember that if it was a substitute, as the price of a movie ticket goes up, people would just be more apt to buy concessions. However, this is very logical also, considering that people buy concessions when they go to the movies. Because it's a complement, people are more willing to buy more concessions when the price of the movie ticket is lower. That is how complements work. And that is everything. Thank you so much.